welcome to 9.5 Lines and Circles. Okay, so for our first theorem, we have the measure of an angle formed by two secants that intersect in the exterior of a circle is 1/2 the difference of the measures of the intercepted arcs. Okay, so we need to do a little bit of translating here. So we have an angle that is formed by two secant lines, and secant lines means they cross the circle in two places, and those lines intersect outside of the circle. That's what exterior means. And in order to find that angle that those two lines make, we need to know the arcs in between. So we're going to look at a figure. I do want you to notice, though, this is 917A. We're going to do B and C after we do 18 and 19, because I think you'll see a little bit of a pattern here. So here we have a circle where we have two secant lines. As you notice, they are not tangent lines, they're secant lines, and they intersect outside of the circle, or the exterior of the circle. Okay, so then we can go ahead and figure what that angle is. So what angle BAE is going to be half the measure of arc CD minus arc BE. So they gave us those measures. So 100 minus 30 is 70, and we take 1/2 of that. Okay, so now we know the angle of BAE. The next theorem is when you have two secants that intersect inside the circle. Okay, it's half of the sum. So when it's inside the circle, we're going to add. When it's outside, when they intersect outside the circle, we're going to subtract. So here we need to know the angle of angle 1, which would also be the angle, which angle 1 is also called AEB, but that would also give us the angle of DEC because of vertical angles. So we would actually be finding the measure of two of those angles, but what we're going to do is we're going to add arc AB and add to it arc DC, and then take half of that. So half of 40 plus 30. Okay, so hopefully we're all on the same page here. So here we have another theorem where we're going to be talking about, instead of the intersection of two lines happening outside of the circle or inside of the circle, this is where they're going to intersect on the circle at the point of tangency, and it's going to be, the angle measure is 1/2 the intercepted arc. So here's a circle, and the measure of arc HI, that is the intercepted arc. So then we can find the measure of the angle HIJ. Now see how angle, the minor arc HI goes into the angle that we want to find? That's what the intercepted means. It's going into the angle that we want to find. So what does the theorem say? It says that we take half of that. So there we go. We know the angle is 60 degrees. So here's an example that's in your book. I forgot to mention that there is a proof over theorem 917A that I would like you to look at. I think you'll find it pretty straightforward. But anyway, moving on to the example. This example is on page 396. So we need to find the measure of angle ABC if BC is a tangent to the circle and B at point B, and line AB is a secant. So AB is our intercepted arc, and they happen to give it to us. So what does the theorem say? It says that we take half of the intercepted arc. So if we plug that in, 85 degrees is the answer here. Now what if, just what if they gave us the other arc? What if they gave us the major arc? Say it was ADB. I'm going to put a D on that circle somewhere. And they gave us the major arc, and we had to find the minor. Could we do that? Absolutely, because a whole circle is 360 degrees. So if we would have subtracted off the major, we will get the minor, which is the intercepted arc we need. I want you to keep that in mind for some of the practice problems that I give you for the whisk summary. Okay, so here we are at 17b, like I said we would be. The measure of an angle formed by a secant and a tangent that intersect the exterior of the circle is still 1/2 the difference of the measures of the intercepted arcs. So I don't believe I have a picture for you, but if you do want to look at one, number 8 in your textbook under the exercises is a really good figure to look at. Basically, you have a tangent, but the intersection still happens outside the circle. So you have a tangent and a secant line, and you'll be able to find all of the arc lengths that you need around the circle. So the intercepted arcs are where the tangent and the secant are in between. So you still have a big angle and a little angle, and you are going to subtract them. That's what the difference means, just like you would if they were two secant lines. So really there's not a whole lot different going on with this. You just have the angles are just going to be larger, really, because the arc lengths are going to be larger because of the tangent line instead of another secant. And then we have the measure of an angle formed by the intersection of two tangents is 1/2 the difference of the measures of the intercepted arcs. Now if you think about this for a minute, two tangent lines means that you have a whole circle. Okay, so like look at, I don't have a figure for you again, I apologize. Number 13 in your textbook on page 397, you have two tangent lines. So I have a whole circle. I have 360 degrees. So my large arc is going to be a part of that 360, and my small arc is going to be the other part, right? And if I subtract those numbers and take 1/2, then I will have the measure of that angle, that angle that's on the exterior of the circle. Because I want you to keep that in mind. You're going to need to remember that the circle is 360 degrees for some of your practice problems. This is just a review of various theorems on circles. This table, I actually have another table for you on the next slide. This table is chords, arcs, and angles, and I just feel like this is kind of a summary already for you. It'll just help you remember the difference between all of these terms. This chapter is very vocabulary heavy, and we're using formulas and just lots of things to keep straight in our head. So I kind of felt like these little charts might help you. So just a reminder, chords and arcs, congruent chords, subtend congruent arcs. So if you have two congruent arcs, then you know their chords are congruent and vice versa. Central angles and arcs, right? And then chords and central angles. So hopefully remember all of these theorems and how to keep them straight and how we can prove congruency in these different parts. And then I have lines and arcs and angles and how they're all related. Now the two secants, these are basically what we learned today. Half the difference of the arc measure, half the measure if on the curve, which is an inscribed angle, half the sum of the arc, half the difference of the arc. So all of these you can write in your own little math language, and I'll show you how to do that in class. But I think this is just a summary again. I hope keep it all straight for you. And now we're in the whisk summary. There are 6 practice problems. I would say number 5 is probably that has the most rigor, but if you remember the 360 degrees around the circle that I gave you, hopefully all of these are going to use some algebra skills. So you'll be solving for x. Make sure you're putting your numbers in the right place, and I will look forward to your submissions and see you in class.